All right, well, welcome everyone. Thank you for coming to this, one of the first sessions here at PDC. Hope you enjoyed the keynote. Did everyone enjoy it? Yep. Hope you learned a lot of cool new things, the launch of Windows Azure. Unfortunately, I couldn't stay for the final part of the keynote, but I understand it was entertaining. Well, welcome to this session, CL09, How Microsoft Visual Studio 2010 was built with WPF. And as it says on the slide, my name is Paul Harrington. I'm a principal developer on the Visual Studio platform team at Microsoft. And for the last year or so, as you know, we've been working on Visual Studio. I led the feature team which transformed this into this. Of course, just one click of the button. Thank you very much. Who here, and I hope to see a healthy showing of hands now, has downloaded the Beta 2 of Visual Studio 2010? Thank you. Appreciate it. Now, please send all your feedback. Get on the Connect website. Love to hear your feedback, particularly if it's something that's going to prevent you from using the product to ship world-class applications. That's, of course, why you're here as well, to learn about how to do that. But I'm going to show you how we also shipped this world-class application, or at least got it to Beta 2. And hopefully we can get it the rest of the way. In this talk, you'll learn how we did that, the kinds of challenges we faced, and then hopefully you'll take away from that, be able to learn from me and my team how you can also apply those techniques to your own applications as using .NET 4, WPF, and the Microsoft technology stack. So I'm going to frame my talk today by answering these 4 questions: the why, what, how, and who. Why did we choose WPF? What features did we use? And I'm going to spend most of the time here today focusing on the how, because that's what you're here to learn. And then I'll wrap up by talking about who on the team was involved. So, without further ado, moving on to the first question: why did we choose WPF? Well, there are 4 reasons, and the first was purely technological. Since the first version of WPF in .NET 3, people have been asking us, customers like you, have been asking us, well, if WPF is so great, should I use WPF in my applications? What Microsoft applications are going to use WPF? I mean, it was brand new at the time. There were very few out there. And for a while, and certainly for a few years, the largest Microsoft application that used WPF was the Expression Blend product, and then parts of the Expression Suite as well, Expression Web, Expression Design. And that was true for many years, and so it was a fair criticism if Microsoft is going to take a bet on WPF, let's, show me the money. Well, now I can reveal, although it's not such a revelation if you've been paying attention, that, of course, Visual Studio 2010, an enterprise-class application, was built with WPF, and here it is. Let that focus. Oh, here it is. Here it is. Now, nearly every pixel you see on the screen here is being rendered with WPF. We have the menu bar and toolbar at the top, status bar, frames around the major windows and the tool windows. The start page itself is brand new WPF. We've got some interesting little animations in there, just scratching the surface a little bit of what you can do in WPF. But there it is. And really, in case you need proof, I'm going to use this Snoop tool. Snoop, if you've never used it, is a WPF kind of spy tool. I have a link to the download of Snoop in the slide deck, which you can access at the end of the talk. And what I'm going to do here, you can see we can browse the WPF visual tree for Visual Studio. In fact, I can do this clever little 3D zoom thing. I'll resize this, make it a little bit more obvious. And indeed, here are the WPF layers being rendered. And you can see the toolbars there stretching from back to front. So you can see how the WPF tree is rendered. So that was the first reason, that first technological reason. And I think we succeeded in proving that WPF is a capable technology for something like Visual Studio, an enterprise-class application. The second reason was architectural. Now, Visual Studio, as most of you realize, is a very mature product. It's been around for well over a decade in the .NET form. And some components are at least that old, stretching back to Visual Basic 5, Visual C++ 6. So those were written at the time when the only presentation technology was GDI and Win32. And when we sat down at the beginning of 2010 to look at our 5- and 10-year roadmap, we realized that these technology choices were not going to be able to support some of the ideas and future visions we had for the product as we move forward. And some of the new user experiences and visual user interface effects that we wanted to put in. So while we didn't choose WPF specifically at that point, we realized that we needed to add or install an architecture to the code base that would enable a separated presentation, that separation of presentation layer from the business logic. The business logic, of course, is where we have that investment. That's our core competence, if you like. That's our intellectual property. But the presentation layer that sits on top of that is where we interface with the customer. And we've made a clear investment over decades now in that business layer, and we want to take advantage of that without sacrificing it or being forced to rewrite it, but at the same time dress up the UI and enable new UI paradigms. So that support for the long-range roadmap and a separated presentation led us to choose a technology that would enable those architectural initiatives, and indeed WPF naturally leads us to that style. The third reason was that we have key Visual Studio 2010 technologies that require WPF. We already had a new managed WPF-based editor that is actually shipped even before 2010. It shipped in the Expression Blend product. That editor that you see there is the same, or at least an earlier version of the same Visual Studio 2010 editor. Managed code, WPF, and it had already been built, and we wanted to bring that technology forward into 2010. And there were other teams. There's a brand new architecture designer in the Ultimate and Premium editions, which uses WPF as a drawing canvas. The Parallel Tools debugging team, they wanted some WPF-based tool windows. And the list goes on. So we had several teams that wanted WPF, and so we wanted to install an architecture and a platform that would support these new technologies, these new features using WPF. And the final version was, the final reason why we chose WPF was really an opportunity that doesn't come around very often. Visual Studio 2010 product and .NET 4 were aligned on their shipping schedules. So when we started 2010, the WPF team were just coming out of their 3.5 SP1 release, and we had an opportunity there to work with them to address existing known issues and to add features that were necessary to prove that first point, that technological point. And I hope that we've been able to take some of that pain, some of those problems, working with the WPF team themselves, and other teams in Visual Studio to come up with a satisfactory solution that you won't have to go through that same pain. You can just springboard from our learnings and the new features in WPF 4. So this slide just lists the features that we used. I'm not going to drill into all of them, but I will call out a couple because they will come up as recurring themes throughout the rest of the talk. Yes, we use XAML. We use XAML as our declarative UI for nearly everything in Visual Studio. So we're not using imperative programming. We are leveraging the designers, the CIDR designer, and in fact, some of our components were developed in Expression Blend and then ported over to the Visual Studio code base. We implemented a new internal layer for data binding. And I mentioned we had those business logic components that we wanted to maintain. Most, if not all of them, were written in native C++ code. And their data models, as we started to add that separated presentation, once we disentangled them from their existing presentation, those data models were, of course, being built in native code. And we wanted to bind to them from WPF. And so we implemented a technology that allowed us to do that. That topic will come up a little bit later as well. We use styling and application resources, just like a normal WPF application. We used heavily that interoperability between WPF and Win32 based. And by Win32, I'm also counting WinForms. Windows Forms is really, with no disrespect to the team, a managed wrapper around an HWind. In many respects, it is. We're leveraging that interop capability. And that's really because we didn't want to rewrite everything in WPF. We just didn't have the time or the resources to do that. And many teams that plug into Visual Studio just didn't need to or want to move to WPF, at least for this version. We needed to integrate with our existing message loop. We weren't able to move to use a managed application object, a managed message loop. And that's OK. That's because we have specific requirements for embedding, for example, embedding Word so Office documents, Word and Excel documents inside the IDE. We have to carefully coordinate our message loops there. So we wanted to maintain complete control over the message loops while integrating with WPF. And again, I've got a slide and a little demo on that later. And then also, we wanted to showcase the new tech stack that WPF, in fact, built alongside us, based a lot on some of the feedback that we got from probably some people in this room around Beta 1. The WPF team implemented a brand new tech stack around the direct write technology. And again, I have a demo of that later on. So I've got the why and the what out of the way. So now onto the how. This is going to cover several slides and a few demos. We took a staged approach. And that's really because we couldn't afford to disrupt the entire team just to stop work and put in WPF in one go. So the first step was to define our data models. Purely a diagramming and architecture exercise. Yeah, a little bit of spelunking through the code, looking for existing data models that might be there, hidden inside that tangled mess. Put in a sensible model where maybe there was none before, and maybe identify the key pieces of existing data models if they were there. So that was an interesting diagramming and architecture phase that we went through just to kind of take stock of where we were and what features we already had. Then the first big change that we made was actually a very small change, but it had an interesting effect. We just replaced our main outer window that was just Win32 create window EX with a managed call to the same thing. In fact, we used WPF's HWind source as a way to create that main window. But of course, we hadn't changed anything on the inside, so that main window is just a big HWind source hosting another inner HWind. But at least we took that first step, and that first step of getting managed code into the process where there was previously no native code on the startup path. That was a big step, and it forced us to solve a few problems. First of all, how to get that interop going, how to hook up the message loop, how to manage that window, how to size it correctly on the screen. And in fact, we even there discovered a feature that was missing in WPF that we couldn't do before, for example, and that is we sometimes need to create our main window without actually showing it. And WPF 3 and 3.5 didn't allow you to do that. So there is a new feature in WPF that allows you to create a window invisibly. We need to do that for automation, for example, and doing command line builds, things like that. So after replacing the main window, then we had to start writing these new managed components. There was a couple of major new components that my team worked on, the window manager and the command bar system. And by command bars, I mean menus and toolbars, context menus, that kind of thing. Now, what we're replacing there, of course, was homegrown Win32. I mean, you can probably imagine how ugly this code was and how many bug fixes over the years and little tiny features and special cases and edge cases. You can probably imagine how complex that old code was. So in many ways, it was good to put it aside and rewrite it, having done the data model analysis and what we needed for a window manager. But truth be told, that window manager had already been in development for a while. And so we had some of the pieces all ready to go. The command bar model, on the other hand, was completely new. We hadn't even approached that problem before. And what we were replacing was, again, almost a decade-old code that we'd borrowed. At first, we were sharing, and then we finally borrowed it from the Office team. And if any of you have ever looked at Office and Visual Studio's toolbars, you'll notice they're very, very similar. The programming model is almost identical, and that's because they do share some code there. Well, that has all been pushed to one side again and replaced with a new WPF command bar. Now, we did all this, of course, we're trying not to disrupt other teams. So these were all turned off by default. On my local team, on the Shell UI team, we, of course, tested with the switches turned back on. But we weren't ready, of course, at this point to turn it on for everyone else. And in fact, the switches allowed us, for a certain period of time, to actually run with both technologies in the product at once. So we could actually verify that the command bars, the toolbars that we were showing, were coming up and rendering the same in both the old and the new presentation layer. That's actually a very interesting trick. I wish we could have used it in more places. But if you're making that switch to a new presentation layer, and you can keep both new and old running at the same time, it's actually a very useful technique. And one I will also say that we borrowed from the Expression Web team, who did a very similar exercise. So after we installed this new window manager and toolbars, of course we keep working on fixing the bugs and implementing those final few features for them. We began to scout test with other Visual Studio teams. And I'm sure you're aware, Visual Studio is a very large organization. There are dozens of product units all working on the Visual Studio 2010 components. Not all of them were aware of the change to WPF, and some of those teams had to be made aware of it. And we scouted with them. We showed them where to get our builds and how to turn on these switches, and to get their early feedback, to get them testing the product, get them aware that we were making this change, and find out how it was going to impact their product. That's a very important part of this process, that we got that early feedback. We were able to iterate very rapidly by selecting just key individuals on those teams and getting them to be our scouts out almost in the field, if you will, with Visual Studio being so large. And then it's just test, test, test. And I really mean you have to test this stuff thoroughly. And UI, I've been on the record before. I was interviewed a long time ago by Channel 9 talking about UI for the 2008 product. And I said, there are so many edge cases with user interface. You think you know how focus works. You think you know how clicks and drag and drop works. But until you've actually written the code and tested it on so many myriad different ways of interacting with your UI, you really don't know how complex UI can be. And you just don't find that from looking at the code. You have to test. And this, I will admit, this is one area that we fell down on. And I have a slide, in fact, talking about this, that don't underestimate that testing impact. I'll come back to it. I think it's on the next slide. And then, of course, once we'd done all that testing, we were ready to go. We flipped the switch for everyone, crossed our fingers, prayed, did the dance, and then waited for the results to come in. Very nervous time. This was back just before Beta 1. So you can imagine we would, it was hit and miss whether we were going to do this for Beta 1 or not, but we did, and we had a safety valve. We were able to switch it back if necessary, just to confirm that if anyone came up with a bug that looked like a new presentation layer bug, that we could flip the switch back and then confirm if it reproduced in the old technology and or the new. And then, of course, this is almost an optional phase, but it would be a shame to leave all that old code lying around in the code base. But once you have finally convinced ourselves that, yes, the new code was good enough to ship, then, of course, we can begin removing all the old code, removing those switches entirely. So, yes, I mentioned test, test, test. And do not underestimate the cost of converting your automated test cases over to WPF. And the most obvious thing, and it should be obvious to everyone in this room, there are no H-wins. It's WPF. There are no H-wins, yet you will probably find that your test code, particularly your automated test code, has assumed that there is an H-win tree that they can go get parent, set focus, get this property, set that property through H-wins. And that's just not going to work in a WPF world. And we also discovered, as we scouted with those teams, that every team had their own little test frameworks. Every team had their own little way of negotiating and navigating that H-win tree. And all of those techniques were liable to fail, and most of them did. But it's not all bad news. There's opportunities there. Of course, opportunities to unify those testing frameworks. And we took those opportunities in stride, having been a little bit burned by the testing costs there. We took that opportunity to unify those testing frameworks around UI automation. So that's the accessibility APIs for WPF. Also works with Win32. We've unified a lot of our testing frameworks. We've made an opportunity there. And there's also this final bullet point on this slide, that opportunity that didn't exist before for our test team to test at the data layer. We didn't have a data layer before. We didn't have separated presentation, but now we do, and we can expose that. And even if we don't expose it, in fact, our testers have figured out how to inject code and find the data context on every WPF visual, and you just cannot hide from our testers sometimes. It's pretty frightening. So they're able to find our data models, even if we didn't put in specific hooks or explicit APIs for them to call. And they use that very heavily to validate that, of course, the data models are staying consistent and up to date without relying on either a visual or manual verification or other hooks for UI automation. So they can test at the data layer. In fact, they can test in both directions. They can just observe the data layer, but they can also poke the data layer. And they love to do that kind of thing to, of course, inject faults. So I don't know how many people are involved in test automation here. I'm sure quite a handful. But this is an opportunity for you as well to peer into the inner workings of your products that maybe you didn't have before. So I'm going to list out some of the challenges here, and then I'll go into detail on not every single one, but the major ones. So if I could sum up our largest challenge, and in fact, if I only had time to talk about one, it would be this, that we are now a mixed mode application. I've said WPF a lot already, but there are still Win32 and WinForms pieces to Visual Studio. And that was our biggest challenge, and it still is today. And it's not going away. We're a highly extensible platform. Anyone can write a tool window or a designer to plug into Visual Studio using, frankly, any technology they want, and they do. We had that internally as well, and even on my local team, on the Shell UI team. So there are a lot of pieces that we didn't want to, or just didn't need to be moved, and obvious ones like the WinForms designer itself. There's no need to move that to WPF. It's a WinForms component. And being that mixed mode application led to a number of challenges. Firstly, of course, is just that native managed divide. I talked about the data binding layer, but there's also interaction models there. I'm going to talk about the message loop and integrating with the message loop. We're writing that message loop in native code, but it does have to make calls into managed code, and those have to be high performance and hopefully as lightweight as possible. And then secondly, obviously just dealing with that hosting and containment of HWinds. With WPF on the outside, on the outer frames, the content itself may be WPF, or it may be something that's HWind based. And as I mentioned before, I do kind of count WinForms as an HWind based technology. We also have to keep all our existing extensions working. It's no use if we put out this wonderful new WPF IDE if none of your extensions, if you're extending Visual Studio, will work in it unless we don't want you to have to go and rewrite all your extensions. So we have to maintain all our old APIs. They're COM-based interfaces, and if you're coding in managed code, we have a managed package framework that many packages use to plug into Visual Studio. Those interfaces had to maintain, if not binary compatibility, at least source-level compatibility. And Visual Studio does have quite a high bar for compatibility. But at the same time, we want to allow new components that are written in WPF to take full advantage of the WPF frame. We don't want to artificially inject an HWind boundary around that component just because that's the default lowest common denominator. If the component supports WPF, we want to be able to host it natively. And I'll show you how we did that in a minute. We had to do all this without stopping the train. And by that, I mean the dozens of other Visual Studio teams that were adding their components and features to the product. That's, as you can imagine, with a large product as the size of Visual Studio, if we had to stop engineering just so we could put in this new presentation layer, that would just be untenable. So we had to do it in that staged approach that I mentioned before. A couple of other challenges that I'll talk about towards the end. Text clarity, and I gave you a hint about that earlier. We worked with the WPF team on a new tech stack, and I'll come back to that. And performance. Now, if many of you had a chance to play with the Beta 1 release back in May, I'll freely admit it, we were slow, we were memory hungry. We had some performance challenges, and a lot of great feedback from you guys, forced us to double down on our performance investments. We made some great strides in Beta 2. Certainly is a lot better than Beta 1, but we're still not quite where we want to be. Now, I'm not blaming WPF for this, but it is that challenge, again, of a mixed mode application. You've got the best and also the worst of every technology mix you can imagine, and that all adds up. So we've got a little way to go before we're ready to ship. Performance is a key issue that I spend a lot of my time on. I certainly spent a long time between Beta 1 and Beta 2 working on this. And I'll talk about some of the tools and techniques that we used later on. So I mentioned the challenges of a mixed mode application. And we got really two challenges there. The interop in the data layer, that managed code now binding possibly to native data models. And we developed a COM interop-based technology for allowing us to do that. Some of you that may have come to the Dev Labs in Redmond may have heard me talk about that technology in the past. That is available for partners if they want to use it, but we're not actually making that public for everyone. But if you are interested, you can come see me or one of my colleagues here. And then, of course, we have the interop in the presentation there, that composition of new and old. Two other challenges that I put on the slide here that I'll also talk about: focus and activation. Focus was a tracking focus in particular was very error-prone. We found a lot of bugs. I mentioned UI is never as easy as you think. We found a lot of focus bugs here that we had to work with the WPF team to solve. We put in new features as well, which I'll be able to demonstrate today. And then integration with the message loop. So I'll be covering all of those points in turn. The first one being composition of new and old. So here is one of our COM-based interfaces. We only had to change a few of these, but there's a major problem with this old IVS window pane interface. I wonder if anyone can spot it. Absolutely, the H-ones on the slide here. The fact that we have H-ones baked into our hosting interfaces. This is the interface that you would implement if you were implementing a new editor or a new tool window in Visual Studio. Well, what if your tool window is not an H-win? What if it is WPF? So we introduced an extension, in fact, almost a replacement for this interface. Of course, we have to keep this one working, but we introduced a replacement for this called IVS UI element pane. And notice, again, this is a COM interface, so we don't mention WPF by name. And in fact, this is completely presentation neutral. We designed this interface without saying anything about the presentation technology. We just said it's IUnknown. So it is an object. And from that object, we can then query. We can use query interface from the native side, or we can cast from the managed side to find out what kind of object that really is inside the pane. And we had to change 2 or 3 of our interfaces like this, where we'd had H-wins baked into them. But the key here is that dual personality of so removing H-wins from the interface and then allowing that multiple personality of starting with IUnknown. And then our frames, correspondingly, our IVS window frames. Now, those are the frames that we implement. Know how to do that negotiation to these new IVS UI element panes. And if that fails, then they'll fall back to the old H-win-based IVS window pane. The second challenge I mentioned was focus and activation. And this demo is going to show you. I'm actually going to attempt some live coding. So cross your fingers or wish me luck. So what I have here is a simulation of Visual Studio. Of course, it could never be the complete thing. It really is very, very simple. Let me just close out Snoop here. I'll show you what I've got. Yes, we should build that. What I have here is a tiny little test app, and I'm going to just zoom in so you can see the whole thing. This test app is WPF. This focus demo test app is a WPF window. It has a menu. It has a toolbar. Very simple simulation of Visual Studio. But there is a native message loop running, and I'll show you that in a second. Within this WPF window, these are WPF menus, WPF toolbars, we have these 2 blue boxes with numbers in them. These are actually WinForms user controls being hosted on that WPF window. So we've got some interop here. We've got some H-win-based interop. The hexadecimal numbers inside the boxes is the readout of the H-wins of the edit box within them. So when I'm in here, I'm using this H1, 00B0A38. And you can also see that that current focus monitor is tracking where my focus is. So if I now click down in this other edit box, then it's changed to 000A0A6A. And so this is tracking focus for me as it moves around. But there are some problems here. And the first one is that the menus don't work. Well, I can click on them, but the menus from keyboards don't work. And this is very difficult to demonstrate, so you just have to watch me from the audience. I'm going to press the Alt key, and nothing happens. Right? Alt is supposed to take me to the menus. Well, why is that? Well, the first thing and the first point of integration is that our native message loop knows nothing about WPF. When that Alt key comes in, it gets dispatched to the window with focus. Window with focus is this little edit box inside my WinForms user control, and it knows nothing about WPF menus. So to fix that, what I'm going to do is in my main message loop, which is right here on the screen. So it's an absolutely standard Win32 message loop, get message, translate, dispatch. I need to make an interop call to a WPF API in the component dispatcher class. This is not a new feature, but it's essential for integrating with the message loop. So I have, now I'll reveal the secret here. There is already, I've written a C++ CLI interop layer to allow me to get from native code to managed code. But all it's doing is wrapping this call that I'm going to write in a little managed thunk so it can call into managed code. So the method is raise thread message. And it returns a Boolean indicating whether it handled the message or not. If the message was handled, then we don't need to do anything else. If it's not handled, then we go ahead and translate and dispatch as normal. So let me build, and let me zoom out so I can. Oh, you're absolutely right. Thank you. Thank you for catching my mistake. I would have got the compiler error. In fact, I think I did. Oh, it's still running. Let me close that. Good. Okay, so now, zoom in so you can see it. I'm going to do my demo again and press the Alt key, and now we've got the menu appearing. And I can, in fact, let me do that entirely without touching the mouse. Alt key, and now I can interact with the menus from the keyboard. Now, did anyone spot the problem here? So the next problem is that the current focus has moved. And the current focus is to an H1 that I don't have anywhere else. In fact, that H1 is the main outer H1, the one and only WPF H1 there is. It's the one that sits on the desktop. And when I went to those menus, in fact, all I did was hit that Alt key. We did a component dispatcher, raise thread message. We ended up with focus now moved to that main WPF window. Well, we had to fix that. And the problem there is that, for example, let's imagine I've got some text in here, and I want to, oops, now the Alt key is just too sensitive. And I want to, say, cut that text. If I now do a cut operation, focus has already moved. So it's going to cut well, it's not going to cut anything. There is nothing to cut in the main window, but I wanted it to cut the text in my edit box. So that doesn't work. So how do we fix that? Well, this is a new WPF feature. There is a feature that stops the main menus from stealing focus. And we needed to do that, of course, for exactly the same reason in Visual Studio. So what I'm going to do is call that method. In fact, all it is setting a property. And I'm going to call it inside my, just after initialize component. It has to be called on an H1 host. I'm sorry, it's an H1 source, in fact. And the new property is called default acquire H1 focus in menu mode. It's probably the longest property name we have in WPF. But it says exactly what it does. Was there a question here? Oh, I apologize. I'm also going to cover this. This is also on the slide in the deck. So if you're missing the actual the method name. You can copy it from the slides later. So let me build, I think, yeah. Let me build and run this. Now this is, hopefully, if I've done everything right. Now I can type here. I can use the keyboard to navigate to the edit menu. And notice that the selection is still there in the edit box. So when I hit cut, indeed it gets cut from the edit box, and then I can do the same thing with paste. Well, that's great for menus, but what about these toolbars? Oops, we've got the same problem. As soon as I click on the cut menu, focus moves. So what I'm going to do is I'm going to click and hold the mouse button. You'll see what the issue is. The focus moved from that edit box. I'll do it one more time. So we're going from CF08CE, which is this edit box. As soon as I click on the cut menu, focus is gone. And so same problem with toolbars. Well, how do we fix that? Now, toolbars are not integrated the same way as menus are automatically through keyboard tracking. But there is a way to do that, and that's with a new property in WPF's input manager called menu mode. And there are various properties, there are methods and events. So there is the is in menu mode property. There is the push and pop menu mode for changing menu mode. And then there is the events for listening to menu mode. And in fact, I don't see it in this demo. In fact, I've already hooked up, yeah, here we go. I've already hooked up event handlers for enter and leaving menu mode. What I need to do is change that toolbar so that when it gets focus, that it pushes menu mode for us. So it'll say, oh, that's a menu mode operation. I now need to go into menu mode, and also, because of the, let's say, default acquire H1 focus in menu mode being false, then it won't steal focus from the currently focused control. So now I will admit that this is part of the demo that has crashed before. So what I'm going to do, oops, I didn't mean that. I just want to move that over. Where's my toolbar? Here it is. Let me zoom in again and see if that helps. So here's my toolbar. I'm going to add 2 event handlers to this. There's preview, so on, well, sorry. Where is it? No, preview got keyboard focus, there we go. It's a little difficult typing while zoomed in that far. Okay, so I'm going to add a new handler for that. So the event is preview got keyboard focus, and then there's also a corresponding preview lost keyboard focus. So I'm going to have a new event handler for that. And, of course, I need to fill in those event handlers, which have been added for me here. And I am going to cheat a little bit because I've got the text here. I'm going to have to edit it once I've pasted it, though. So I need to get rid of these guys. Okay. And let me just fix up my curly braces and zoom in a little bit so you can see what's going on here. So here are my 2 event handlers. The key methods here is when I get keyboard focus, I'm going to be calling push message mode, menu mode, pardon me. And when I lose keyboard focus, I'm going to be calling pop menu mode. And this is a presentation source that you pass into push and pop. This is the visual that is going to hold on to menu mode for you. And I notice that I'm storing it away in this presentation source. So I think I'm still running it, which is why. Oh, no, what did I? I think someone preview got keyboard focus. Lost. Oh, I'm sorry. It's not preview lost. I just want lost keyboard focus. My mistake. once again. I think I just need to rebuild. Here we go. I told you this was the fragile part of the demo. All right, so finally, here we go. I'm going to use the toolbar now. So here I am going to click and hold on the cut menu. You'll notice the focus does not move. Notice that little in menu mode popped up there. Maybe I should zoom in. I'll do this a second time when I zoomed in. And when I let go of the cut, the command executes, and it gets sent to the control with focus. So here it is once again. Hold down cut. I have that in menu mode readout because I'm hooking the enter and leave menu mode events. Let go, and now the toolbar is acting just as we did for menus. So that's the integrating with the message loop and focus demo. And how are we doing for time? We're doing good.
Question?
Oh, is there a question? Yes, go ahead.
Is that only for command for toolbars, or can you make any?
You can make any. Well, in this case, I'm hooking the preview and leave focus on the toolbar, but it could be any control. Yes. The question was, is that just for toolbars, or can it also apply to other controls? And indeed, it can apply to other controls. So we talked about the raise thread message method. We talked about that long name, which you can read now. What I didn't mention is that, in fact, if you're using WinForms and the WinForms hosting interop container, that WinForms host control actually implements some additional focus tracking. I didn't get a chance to, because I'm running a little bit behind time here. I didn't get a chance to demo another bug to do with focus in those HWin hosts. But the WinForms host actually takes care of a lot of some of the subtle plumbing there, also to do with focus. And we talked about menu mode. Now I've mentioned the text clarity before. In fact, we got a lot of feedback from Beta 1. Beta 1 customers said, when I look at this text in the new editor, it's kind of fuzzy and blurry. And in fact, we had some people saying, this editor is making me physically sick. I'm getting headaches if I use this editor for a long period of time. It's interesting. It's a human psychological or physiological issue. Some people are affected by it. Some people are not. What's going on here is that WPF has its own anti-aliasing mode using subpixel sampling. Works very well at high DPI. Works very well for large fonts. But for small fonts on a relatively low DPI, and 96 DPI is actually pretty low for most, and it's the normal DPI for most laptops and flat panel screens. With small fonts, that's actually comes out blurry. So we went to the WPF team and said, well, what's going on here? And they said, well, it's not blurry, it's ideal. And I said, well, what's ideal about it? Our users are getting headaches. They said, well, okay, well, let's take a closer look at this. And yeah, as I described the problem in low DPI, the fonts can become blurry. So they worked with us on this new stack, this new tech stack. We're really pleased with the results, actually. It's come out very nicely. And instead of ideal, they now have display mode. And this next demo, I'm actually going to breeze through this and just go straight to the demo. This next demo demonstrates both the problem and the solution. It's very quick. I'm going to use XAMLpad here, running on WPF4. And again, let me make this smaller and then zoom in. So, it's blurry. In fact, you'll notice that XAMLpad has blurry text as well itself. XAMLpad, of course, was written before WPF4. I'm going to zoom way in so you can see what's going on. Now, I will also say, and we tried this before you guys came in, that there is also a little bit of smearing on the video projectors in the room. But if you take a look at, for example, the plus signs, you'll notice that they're not all even. There are some that are a little smudgy, some that don't quite align, particularly in the left to right horizontal. Can you all see that? Yep. So I've got a second text box here, exactly the same thing, and I'm now going to apply the appropriate fix. And so here's the second text box. The new property is an attached property on the text options class, and it's called text formatting mode. And instead of ideal, which is the default, I'm going to set it to display. Okay, now let me zoom back in again. I'm going to paste in that text. Now hopefully you'll be able to see the difference here, particularly the plus signs and the vertical bars. The lower image is using display, the upper image the upper text is using ideal mode. And at this, oh, thank you. Thank you very much. So we've certainly gone a long way to alleviating some of those headaches, and real headaches, real physical headaches, using this new text stack. We could difference in performance. That's a great. I'm going to have to refer you to the WPF team. The question was, is there a difference in performance? It is an entirely new stack, so there is a difference. We have not, I don't have the data right in my head on whether it's faster or slower, or whether you'll be able to notice and what the throughput really is. For us, we use this in the text editor, and we now have we do have a faster text editor for scrolling, and well, IntelliSense, but scrolling in particular in the 2010 editor than the native code. There's one other feature I can show you. Now, there's still also some anti-aliasing going on. You can see that the WPF is trying to apply clear type here. Up until WPF 4, it was never possible to turn off clear type, regardless of whether your operating system had that option, whether you turn it on or off as a user setting on the desktop. And you'd even on situations like remote desktop, where we were using software rendering, you still couldn't turn off clear type. Well, now you can in WPF 4. It's also another attached property on text options. Let me show you that one. It's text options text rendering mode. And I'm going to, instead of, so the default is clear type, I'm going to say I actually do want aliased text. Aliased is the opposite of anti-aliased, right? And so there you go. Now, this is not something that we'd recommend for everyone, but it certainly shows you that we can now do aliased text, and it's a little bit of a, a mind bender why you would want to do that, but it's certainly possible to do it, and it works very well for small fonts, and some displays that don't work well with clear type can benefit from aliased mode. Okay, so that's my direct write demo. Where did I put the clicker? Performance. There was a question about performance earlier. We spent a lot of time on performance, as I already mentioned, between Beta 1 and Beta 2. And the key thing here with startup is, well, in 2008, we were actually able to start the whole IDE without even spinning up the CLR. There's no managed code on the startup path. Well, now, of course, with WPF, it's unavoidable. In order to get that first pixel on the screen, we've got to load the CLR, WPF, this new direct write text stack, in order just to put that first pixel on the screen. So we did spend a long time tuning that. There are improvements in CLR4, there are improvements on the Visual Studio side, there are improvements in the WPF side in order to get our startup performance back where we want it. Definitely took a hit there. I mean, it's not as snappy as 2008. For all the reasons I've said, but it is much improved over Beta 1. A little hint for you, if you're making changes to the visual tree, and by this, the most obvious case for Visual Studio is when we switch tabs in the document. Well, when you're going from one document to another, what we're really doing there is we have a tab control, and we're replacing one framework element with another. Well, the key here is to try and make that operation as atomic as possible. So if we're going, say, from a design, let's say the WPF designer to text editor, we want to make sure that text editor is fully rendered and fully visible and fully ready to go before we make that final atomic switch in the tab control to switch out its presentation source. And we find that kind of optimization all over the place. Another example was switching from design mode to run mode. When you hit F5 to debug, we've got a lot of windows that switch. Memory usage, we've got all those technologies in play, and so we get the kind of worst of both worlds as well as the best and advantage of their techniques, of their technologies. A couple of tools I want to call out, and again, these are in the resources slide at the end. VMMap from sysinternals. Actually, I was just having coffee with Mark Rusunovich. I didn't even know who he was until he introduced himself and said, "Oh, I'm going to talk about VMMap in my talk," and he was very, very pleased with that. So that allows us to look at image loads and memory usage in general for Visual Studio. We've made a lot of good use of that since Beta 1. There is the Windows Performance Analyzer, and again, this is mentioned in the resources slide. Internally, we call that XPerf. I think that's xperf.exe. Very useful for getting that low-level detail from the OS's point of view, what's going on for performance. It gives you everything from CPU, context switches, page faults, I/O. It's been very useful for us. And a quick note on hardware versus software rendering. We do work across remote desktop. In fact, a lot of users are now using virtual machines where software rendering is normal, so there's no hardware acceleration on these virtual machines. And Visual Studio, in fact, does look at the rendering tier available and adjust its visual effects. So, for example, we turn off animations, we turn off gradients, for example, particularly over a network, over a remote desktop environment. You want to save on network bandwidth. And so a gradient fill is more expensive to compress than a solid color fill. So we go back to solid colors for remote desktop. And then a note that scrolling in the editor, particularly over remote desktop, was a performance issue for us. I don't have time to go into this right now, but there are a couple of improvements there for scrolling. We can talk about those offline afterwards. So finally, who was involved? Well, actually, it was quite a small team, only 7 developers and 5 testers in its core. Of course, we had the resources of the entire Visual Studio, WPF, and CLR team at our disposal, but it was quite a small team. Of course, I want to give a big thanks to the WPF team that worked alongside us, helping us through problems, understanding where the issues were, and then being willing to work with us. And then also some of our early interviews that we conducted with the Expression team, particularly Expression Blend and Expression Web. And I should mention all the Expression suite, to be honest. They were all able to give us some great advice on how to do that Win32 to WPF interop and that transition. And I hope you found this talk useful, and I hope you'll agree with me that Visual Studio 2010 is a demonstration that you can put WPF into an enterprise-class application. I'm very proud of it, and I hope you'll agree with me that it's going to be a great success. Some other WPF sessions up here on the slides that I hope you'll get a chance to attend. You can certainly come and find me. I'll be hanging around with the other WPF guys for the next 2 or 3 days, so you can come up and ask me questions. Here's the resources, and there is, unfortunately, there's no time at the moment for questions. Well, maybe we've got time for just one question, if I can. Yeah, go ahead.
Question: when you mix in the native and managed windows, especially when you have windows overlapping each other, did you have problems with the airspace issue where basically all the
Yeah.
ended up on the bottom?
So the question is about the airspace issue, and yes, we did have problems with that. We have to think very carefully about how to handle particularly our sliding windows, our auto-hide windows, and how those lie on top of the main window. I'll have to come talk about that. As people are leaving, please remember that your feedback is important. Please fill out the session evaluation forms. And I don't know if it's been announced yet, but the PDC organizers here are going to be donating money for every attendee that fills out a form. So if you fill out a form, $1 goes to the Boys and Girls Club of LA. And if you fill out 5 forms, they'll double it to $2. So please fill out the forms. It's very important to get that feedback so we can improve PDC in the future. Thank you very much for your time.